Now the question is how the potentiometer is a useful circuit for me in the measurement context. Many physical phenomena, we can convert their change into a resistance. We use that couple of sensors like a strain gauge, change the stress, the strain, into a change in the resistance. Like the thermistor, also convert the change in the temperature as a change in the resistance. Okay, so what's wrong with that? Nothing wrong. However, if I want to have a continuous monitoring system, then I need to connect these sensors into a data acquisition system. Data acquisition systems, including microcontroller, they can only accept voltage. They cannot measure resistance. So I need to convert further this change in the resistance into a change in the voltage. So to sum up, we have a physical phenomena, we convert it into a change in the resistance. And then this change in the resistance, we convert it back to a change into a voltage. So the potentiometer here, it is, as we mentioned in the previous video, it has three terminal device. Between 1 and 3, it's a fixed resistance, which is basically R1 plus R2. Now terminal 2 is connected to a wiper so that you can change the resistance of both R1 and R2 actually, but their summation will stay the same. So using the principle of voltage division, V out, which is the voltage between 2 to the ground, is equal to Vn, which is a fixed quantity, doesn't change, times R2, which is a variable, divided by R1 plus R2, which is also a fixed value. So in this equation, you have only R2 is the one that is changing. So hence V out will be proportional to the change in R2. So I'm converting the change in the resistance into a change in the voltage. Now this voltage, I can take it to a data acquisition system for continuous monitoring. So let's do a demo here. So this is my potentiometer. I connect between terminal 1 and 3, as you can see here, 10 volt. And then between 2 and 3, I'm doing the measurement. So here my knob is somewhere in the middle. So we have 3.78 volt. Now notice when I start to decrease R2, what happened in the voltage? It is changed to almost 0 when I make R2 equal to 0. So if you go back to the formula here, your V out is equal to Vn times R2, and R2 here is equal to 0. Now, when I start to increase the value of R2, as we move, now the voltage start to increase. Now, what will happen to the voltage here I'm measuring when I go to the far end? Guess what? It will be exactly this voltage. Why? Because now, go back to the equation, your R2 is become R1 plus R2, so your voltage V out becomes equal to Vn because this will cancel with each other.